Number 6 says a block of weight 6.1 newtons is at rest on plane at an angle alpha to the horizontal where tan alpha is 11 by 60. So again we can make the split. This is alpha where tan is perpendicular over base. Using Pythagoras theorem, 60 squared plus 11 squared whole square root, getting 61. So we can use sine cos tan. The coefficient of friction between the block and the plane is mu. A force of magnitude 5.9 Newton acting parallel to the line of greatest slope is applied to the block as seen in the diagram. First part. When the force acts up the plane as shown in the diagram, the block remains at rest. So if it remains at rest, we know friction is actually greater than the applied force. So I'm bringing this diagram down so don't have to move up and down again and again. This is angle alpha. We are going to split the weight in two. This is alpha. Weight of the block is given, which is 6.1. So this is 6.1 cos of alpha. This is 6.1 sine of alpha. And applied force is 5.9 newtons. When the force acts up the plane, the block remains at rest. Now basically this force is actually tending to move the block up. So friction will be downwards. So we know friction is equals to mu r. This is friction. Now let's write, and this is r. So right hand side force is equal to left hand side forces. I can see three of them, 1, 2 and 3. The friction towards left hand side plus 6.1 component of weight, that is 6.1 sine alpha and 5.9. Now friction equals mu r plus 6.1, where sine alpha, using the same triangle, sine alpha is 11 by 61. This is not the compulsion that you should use this. If you wish, you can actually find alpha and use it according to your wish, but that would not give you exact answers. That is rounded in decimals. Is equals to 5.9, and where r can be seen from the diagram, r is equals to 6.1 cos alpha. So mu into 6.1 cos of alpha plus, meanwhile let me simplify this, is 6.1 into 11 by 61 gives me 1.1. 5.9, and cos alpha from the same triangle is 60 by 61. So mu into 6.1 into 60 by 61 is equals to 5.9 minus 1.1. Mu 6.1 into 60 by 61 is 6. 5.9 minus 1.1 is 4.8. So mu is equals to 4.8 by 6. And mu is 4.8 divided by 6, 0.8. And one assumption which we actually took when we started, that friction is greater than that. So it is greater than equal to 0.81. 0.8. Second part of the question. Second part says when the force acts downwards the plane as shown in figure 2, the block slides downwards. Show that mu is less than 7 by 6. So same diagram. This is angle alpha. The weight is 6.1. Split it up. This is still alpha. 6.1 cos of alpha This is downward 6.1 sine of alpha, and now it is moving down, and applied force was 5.9. Friction would be upwards. So again we write the equations. Upward is friction and downwards is 5.9 plus 6.1 sine of alpha, component of weight. Now we know that it is actually moving down, so downward forces are more than the friction, so I can say it is less than, friction is less than all the other forces. Replacing friction with mu r less than 5.9 plus 6.1 sine alpha. Sine alpha was 11 by 61, copying it from the second part, 11 by 61. Mu and r is 6.1 cos of alpha less than 5.9, and 6.1 into 11 by 61 is 1.1. Mu cos of alpha, cos alpha is 60 by 61. Is less than 5.9 plus 1.1 gives me 7. Mu 6.1 into 60 by 61 is 6. So mu is less than 7 by 6. Shown. Third part of the question. Given that the acceleration of the block is 1.7 meters per second square when the force acts down the plane, find the value of mu. Acceleration is 1.7 meters per second square when it is moving down. So when it is accelerating, I can say F net is equals to ma, F equals ma. Now net force means forward force minus backward force. So we know the forward force is the applied force, which is 5.9, and the component of weight is also helping it. This is alpha, and this would be, this was weight was 6.1, so 6.1 sine alpha plus 6.1 sine alpha. These are the forward forces, and the reverse force is the friction, which is mu r equals ma. Now if 6.1 is the weight, mass would be 0.61, and acceleration, what was the acceleration? It was 1.7. Acceleration is 1.7. The only unknown is r. So 5.9 plus 6.1 sine alpha. This 6.1 sine alpha is 1.1 minus mu into r. R all the way is 6. Is equals to 0.61 into 1.7. So let's simplify for mu. 5.9 plus 1 is 7 minus 6 mu is equals to 0.61 into 1.7 is 1.037. 7 minus 1.037 is equals to 6 mu. 7 minus answer is 5.963 over 6 is equals to mu. So mu is equals to 0.9938 and recurring. So approximately mu is equals to 0.994.